let's come to question 9 in the homework 3. The question provide us 8 pole zero diagrams and 8 impulse response, and ask us try to match the diagram to the correct response, and just use basic reasoning but not use other analytic tools. So we firstly have a look at the first diagram. We can write the from the diagram we can write the expression of the h of the system. From the picture we can figure that the zeros are 2 zeros, and the poles one of the poles is about 0.5 and another is about minus 0.8. So we can write the expression into this form, and we do the reverse transform of the hw3. We got h of n is to this expression, can be written into this expression, and this composed of 2 parts. The first part is the figure is like this, and the second part is like this, is the double side. And when these two plus together, only the we can find that only the in these 8 pictures only the 6 response is will be possible, because the double side and the upper side is larger than the downside. Now let's come to the diagram 2. Diagram 2 only have 1 0 and 1 pole, so it can be write into and the pole is about 0.7, so it can be write into this expression, and like this. And it from the expression we can know that the response will be normally decreasing, so the response will be the first one. And now we can choose another which is easy to judge. That is the number 8 diagram. Because the pole is outside the unit circle, so the system will be unstable. So we have a look at the 8 response picture. We can find that the response 4 is unstable, so the diagram 8 is matched to the response 4. Now we have a look at the diagram 3. It can be write into this expression, and it's a little bit complicated, but we can write it into this form and do the reverse transform. It can be write into this. The first part is expression with the sine function. That means that this part will decay in a sine-like way, which will oscillating. And the second part is the it is like the diagram 2. It will be also, so it will also monally decreasing. So the monally decreasing part will make the first part. Just remember, the first part make the function make the response oscillating. So this response will be like something oscillating oscillating far away from the 0 point. We have a look at the several picture. The response 7 is correct to the analysis we have just mentioned about. Now let's choose the diagram 7. We can make it bigger and we draw a picture like this. Omega 0 is pretty big, and this means the frequency is big. But it is big, but it's also a little bit less than the pi divided by 2. So we can suppose it pi divided by 2.5. Now we can get the t will equals 5, and we can find out that the response 3 is like this. And diagram 4, when it comes to the diagram 4, we'll find that the frequency is relatively lower. We can imagine the omega 0 equals pi divided by 10. So this t will be 20, and we can from the figure we can find out that the response 5 will be similar to this one. And now let's only left the diagram 5 and 6. Have a look at the 5 and 6. It looks like that they have the same frequency. But the value of the pole point and the diagram 6 is larger than the diagram 5, so it will make the system decays faster in the diagram 5. So the diagram 5 will be now we only left the impulse 2 and 8, and so the one which decays faster will be the picture matches to the matching to the diagram 5. So the diagram 5 will be impulse 2, and the diagram 6 will be impulse 8. That is the solution of all this question.